complete the following chemical equations. In this video, I will explain these two reactions only. I will explain this one later in another video. And you should know the activity series of metals before you solve these problems. So I will have to list metals in the activity series from the more reactive metals, the most reactive metals: potassium, lithium, sodium. They are in group 1 in the periodic table. The next group 2 metals: barium, calcium, magnesium. The next aluminium, group 3 metals. The next metals are transition metals: zinc, iron, nickel, tin, lead. I will place hydrogen here in order to distinguish more reactive metals from less reactive metals: copper, silver, and gold. According to this activity series, we can realize that copper metal, silver metal, gold metal cannot reduce hydrogen ion. Therefore, copper cannot react with hydrochloric acid. But in case sodium, which is more reactive metal, can reduce hydrogen ion, so sodium chloride and hydrogen gas, this one, this is possible. In case of copper and sulfuric acid, its reaction occurs. I will explain the reason from now. The copper and concentrated sulfuric acid. Okay, I'll withdraw the beaker roughly and place metal chip, copper metal chip here, and add sulfuric acid. Too much sulfuric acid, too much concentrated sulfuric acid, and then heat in order to raise the temperature. In high temperature, sulfuric acid decomposes oxygen radical, sulfur dioxide, and water. These gases expand to fill the beaker. So oxygen radical is very reactive metal. This very reactive atom, this very reactive oxygen radical atom oxidizes rust copper metal, so forming copper oxide. This is classified as a base. Okay, and copper oxide reacts with concentrated sulfuric acid. And this one, copper sulfate, salt, and water. This is called neutralization reaction, and add them and cancel oxygen radicals, and copper oxide cancel. Therefore, copper metal and lots of sulfuric acid and salt, copper sulfate, and water and carbon and sulfur dioxide. We have got completed equation. I think this one is very important because it allows me memorize the experimental process. The next one, I will show the process of using electrons. In case of sulfuric acid, it is aqueous solution, so I can express it as net ionic equation, 2 hydrogen ion and sulfate ion. If this solution gains electron, and sulfur dioxide and water are produced. So balance. Right hand side 3 oxygens, left hand side 4 oxygen. Therefore, we should add water molecule or more, and this will be 4. Okay, so how many electrons are needed? In order to check that, we should know oxidation number of sulfur. This one and this one changes, and 4, 2 minus, and I will let X be the oxidation number of sulfur and oxidation number 2 minus. Therefore, X minus 8 equal minus 2 because of this one, 2 minus. This will be 6. And this one, SO2, X and 2 minus, and X minus 4 equal 0, X equal 4. Okay, oxidation number of sulfur decreases by 2. So, 2 electrons are needed. Yeah, 2 electrons are needed. 2. Okay, and then we should know these electrons are released by copper metal. Copper loses 2 electron, valence electron, and copper ion. Okay, so add them, and 2 electrons cancel, and copper plus 4 hydrogen ion and sulfate ion, and to form copper ion and sulfur dioxide and water. Okay, and sulfate ion's oxidation number 2 minus, so it needs only 2 hydrogen ion. Therefore, H2SO4 and copper and 2 hydrogen ion are left, and copper ion and sulfur dioxide and water. Okay, and because of this, I will add sulfate ion to both sides. Sulfate ion both sides, and therefore copper plus 2 sulfuric acid and copper sulfate, sulfur dioxide, and water should be first, and sulfur dioxide. Okay, we have got completed equation by using electron.